today I came after a long time because I was making some journey by road to my hometown during this school holidays, so I could not able to post more videos. Sorry for that, but onwards I will be regular posting my videos. And one more request, kindly share my videos more to your contacts and subscribe so that I'll get more interested posting new and interesting videos. So today I will start again with a geometric problem. Okay, so let me explain first the condition of the problem. There is a square called ABCD, A, B, C and D. A half circle is drawn taking two diagonal corners and extending up to point where AB, if I extend, will meet at E. Okay. Another two circles, which is one smaller circle touching the half circle and one bigger circle touching the half circle is drawn, which respectively touches the two sides of a square. The first smaller one touching DC and AD, and the bigger circle touching the other two sides, that is AB and CD. Okay, so kindly excuse me because I'm not able to draw it perfectly, a perfect square, perfect circle. And one other thing, the centers are given as K and H, where if K is being extended up to AB, it will touch at some point, and this point, if I merge from H towards the vertical drawn from K, it will meet at point J, and that K is extended to the side of the square, it will meet at L. So these are the thing given. Now condition is that the side AB is equal to side B is equal to BC. These are equal. This is obvious. If it is not even given, you can understand that if it is a half circle, it is a square. From there, these are the radius of the half circle, so it must be equal. But it is given, so no problem in that. And another thing is that ABCD is a square, that I have told already. Okay, this is a square given. Now you have to find the ratio between JH upon LK. This ratio you have to find. Okay, so let me start. Before starting, I will draw the diagonal D and B. I will join the diagonal B and D, and from the symmetry you can understand this must pass through the center of this circle, because these sides are touching this side circle, and this of other two sides of the square is touching this circle. From the symmetry you can understand that the diagonal which is joining D and B must pass through the center of the circles. Okay, now I am again extending this JH up to this side of the square, and I am naming it as H dash, let's say, and this point I am naming as K dash. Okay, so if I see these two triangle DLK triangle and triangle DH dash and A, I can say these are similar triangle. Why similar? This is common line, this is common line, these are parallel lines. Okay, because both are perpendicular to the sides, so these are making 90. So from this these two parallel lines cut by two other lines will make the triangles similar. So these are nothing but the similar triangle. Okay, You just see it see in your textbooks. You will come to know clearly why I'm saying it is very easy to understand. These are similar triangles from the properties of the similar cones, because this is a common angle. These are 90 equal, and these are parallel lines cut by a single line, so this must be equal. So these are three cone three equal cones of two triangles, so makes the triangle similar. So these are similar triangle. From there, if I take the ratio of similar sides, this must be equal. This is the property of similar triangle. So if I take the side LK against diagonal DK, it must be equal the similar sides. For this triangle it is LK and DK. For this triangle it must be the base H dash, okay, upon the diagonal DH. Understood? Okay. Now LK upon DK. What is LK and DK? If I take this part, this is a square, because this is touching the circle, and if I draw it, it is a radius again. This is a radius, so this is a small square where DK is the diagonal. So DK is nothing but root 2 times of any of the sides of this square. Let's say LK is one of the sides, okay. So DK is nothing but root 2 times of LK. So LK upon DK, if I take LK upon, so LK is smaller, so 1 by root 2. Okay. Now H dash. What is that? H dash is nothing but JH plus this one, JH plus JH dash. H dash is nothing but JH dash plus JH. I am dividing it in two parts. Okay. Now DH. What is that? DH is nothing but this part, this part, DK plus KH, means DK plus KH. See, this part is equal to this plus KH. Okay. Now if I put the value JH nothing but LK, this again LK plus JH, I am taking this JH, and here DK is nothing but again root 2 times of LK. I am putting the value root 2 times of LK plus KH. What is KH? This KH is what it is, as because these two circles are touching each other at point, so this must be radius of this and this must be radius of this. So this is nothing but equal to the LK and JH, because these are the radius. So I can, if I represent KH in terms of LK, KH nothing but LK plus JH. Is that clear? Okay. Now if I rub let me rub it to have some space on top. So this equation becomes 1 by root 2 is equal to LK plus JH, LK plus JH upon this one becomes root 2 plus 1 LK. If I take LK common out of this, plus JH, I put it like this. So if I cross multiply, so it becomes root 2 plus 1 whole LK plus JH one side equal to root 2 LK plus root 2 JH. I am multiplying this. Okay, so if I keep it LK one side, so root 2 here, if I bring it this side, the one root 2 LK will be subtracted, only LQ will be remaining, and here JH with that side, so root 2 minus 1 JH will be there. Okay, now if I what I have to find, JH upon LK, so I am moving the LK below JH, so in that way the equation will remain as root 2 minus 1. So if I make some calculation and multiply with root 2 plus 1 at the below denominator, so this becomes root 2 whole square minus 1. So root 2 whole square means 2 minus 1 is 1. So it will remain as root 2 plus 1. So this is your ratio. JH upon LK is will equal to root 2 plus 1. So I think it is very interesting problem. It can be solved in another way. I will show it in next video. So there is another way of solving it. So I will show it in next video. And thank you for now. Good night. Please subscribe and share my videos in your contacts. Thank you for now.